Welcome everyone to the ZPNC session. In this session, we've got John Baker from IntelliMagic, who's going to be presenting on multi-period service classes. As always, we would really appreciate any session feedback that you can leave. This session is 6AV, and I'll paste a link in the chat box so you can leave session feedback at the end. We'd also be grateful if you could kindly donate to our nominated charity of the year. We'll give you the chance to take part in our raffle. In terms of Q&A, feel free to ask any questions along the way, and John will be happy to answer those. And yeah, so with that in mind, over to you, John.
Thanks, Chiara, and thanks everyone for joining. My name is John Baker from IntelliMagic. I'm joining you from my home office just outside Toronto, Canada. On the one hand, it's a shame that we can't be all together in person in the UK. I do absolutely love the GSA UK conference. It's one of my favorites. But I suppose one of the benefits is people can join from all over in whatever time zone you're in and take part. And just to echo Chiara's point and advance the slides here, you know, this really is an excellent event, really good content, and it's free. So, you know, by all means, dig deep. These are excellent charities that Mark and the team discover, and it's a good way that we can kind of do our part. Just gonna check chat. Okay, screen here. All right, let's get going. So fairly straightforward agenda. We'll do a little bit of background and context on the metrics that we're talking about, some definitions, important references, look at some actual examples of real data, talk about when and how to use multiple periods, measuring and validating results. It wouldn't be an IntelliMagic presentation if it didn't have a whole bunch of charts and numbers for you to look at. And then in the end, I'll kind of give you my own thoughts on the subject, and should have time for some of your questions. As Chiara said, you know, feel free anytime to ask questions, but we should also have some time at the end. I will try to check the chat box. If you could help me out, Chiara, if there's something there and I don't notice it, feel free to give me a verbal poke. So when I started thinking about this presentation some months ago, this was triggered by what many of you may know, ZOS 2.5, which has just come out, made a pretty significant change to the way that service units are measured and managed in a workload manager context. And we'll get into those details, but suffice to say, this is not a bad thing. It's a good idea. It's just something you need to be aware of. So, you know, many of you today, if you have not been around the performance space for a long time, there's a lot of new people joining, in which I think is great. We need more performance people in the mainframe space. But if you're not, you might be unaware that workload manager isn't the real brains behind the operation, to put it bluntly. It's SRM, the System Resources Manager. He's been around for a long time. He was around before Go Mode, and he's still there, you know, working the levers under the covers. Workload manager is really just more of a collector, and then passes things on to the SRM. Now, service units as another metric, because what we needed is more metrics. They provide a means of measuring resource consumption, and this could be for chargeback or for general accounting. And it's like CPU time, but as we'll see, service unit values for static workload are designed to be fairly consistent across hardware. So, you know, a given job that uses, say, 30 seconds of CPU on your machine today, you run that job and you upgrade the hardware, for example, you get a new machine, it's way faster. Now that job only uses 20 seconds of CPU. But across the two machines, if none of the other values are changed, the same job doing the same amount of work should use a similar number of service units, and that's where the accounting comes in. And listed here, these are the 4 categories of service that may be measured. I'll say today with an asterisk, being that if you're not yet on ZOS 2.5, but again, we'll get into that. a specific point, just as you look through these, if you're not familiar already, TCP, SRB, IO, MSO, main store to occupancy. If you think about what they really mean, IO performance is not so much of a heavy cost driver anymore, and really memory is fairly cheap and plentiful. So the real focus is on CPU. So this is just a quick sample of some jobs from SMF30 data. As you can see, within these data sources, you can see these types of service units can be found in the 30s, also in the 72s. And you can kind of see the obvious very heavy weighting towards TCB time, which makes sense. That's where most of the work is done. The names have been changed here to protect the innocent. Notice also here, we're only dealing with consumption. If you are, spend your time in a workload manager role, you might be thinking about using versus delay samples, which kind of sounds similar, but they're not. That's another perspective from the WLM side of things, and that's only available in the Type 72 records. In the Type 30s here, we're just measuring consumption. We don't really have the concept of delay in an interview event. That's not going to have really a substantial impact on the amount of service that a job uses, whether it runs for 10 seconds or 10 hours. It may be delayed for CPU a whole bunch of time, but in general, if it's delayed, then it's not accumulating service. And what we're concerned about here is how much service was consumed. Now, how you weight WEI, GHT, these four metrics is variable up until recently, which leads us again to one of the key points of what we're going to be talking about today. Prepare for the future. If you're moving, as many of you will be, towards ZOS 2.5, the units you saw on the last slide are initially what we call raw measurements, raw service units, and then they are weighted in WEI, GHT, weighted by your WLM coefficient settings. Again, until you move to ZOS 2.5, and then there are no coefficients at all, and we'll again get to that. Now, these are sysplex-wide values that you set in your WLM definition. That's where the coefficients are. The coefficient values are multiplied by the raw service unit values that are collected as jobs transactions run, resulting in weighted service unit values. They're simply multiplied. The coefficient values multiplied by the number of service units that are accumulated in each bucket. Now, the original purpose of these weights was to allow installations to customize the relative contributions of each category of service. So it's not so much these absolute values that are important, the 10 versus the 5 versus the 1. It's the relative comparison of the four of them. So you take those default values, CPU and SRB, which is also CPU. It's just CPU done on your behalf by the system. They count twice as much as IO. Those values are 10, twice as much as 5. Again, don't worry about the absolutes. The fact is, for accounting purposes, this installation using those values has decided that they're going to charge applications twice as much for CPU time as they are for IO activity. That's kind of the general concept. Now, another more practical consideration is, as the machines have got faster and faster and faster, and now you get into millions and millions and millions of service units, and then if you're going to multiply them by 10, well, you're going to fill up these fields. MSO at 0 simply means, in this example, they're not charging for how much memory an application uses. Main storage occupancy isn't just, it's not really so much how much memory you're using, your working set. It's a calculation of the memory that you're using while you're also consuming CPU, but it's not really important, that important for the purposes for our discussion. Because as you can see in the bottom values, which are the strong recommendations today by everyone, and by the way, this is where they're going to go whether you like it or not. The point at the bottom of the screen, this is literally what will happen as of ZOS 2.5. So what this is reflecting is that we really only care about CPU. Coefficient values of 1 effectively remove weighting. Again, not W-A-I-T, W-E-I-G-H-T. So your unweighted values and weighted values are effectively going to be the same thing. Your unweighted CPU service units and your weighted service units. Really, if you think about it down the future, the terms weighted versus unweighted are really just going to fade away because they won't be relevant anymore. And you can use these, you can get these unweighted values from your SRM constants, which we will talk about in a minute. So now while I'm saying do this, don't just jump. I'm not sure if there are any Spaceball fans on here. I probably need to take this picture out before I share this deck. I'm sure I could be sued by Mel Brooks or someone else. Anyway, it's one of my favorite little movies. And of course, one of the humorous themes throughout the movie is you're prepare this, prepare that, prepare ship, prepare to go. In this scene, they're saying, you know, prepare to go. And of course, the guy in the helmet finally says, you're always preparing, just go. So he just goes. Driver hits the gas and the guy in the helmet falls on his butt in the seat. It's a little bit silly. You do want to do this, but you do want to prepare for it. And again, I'm not talking about the movie now, I'm talking about your coefficients. If your current coefficients are anything other than the recommended values of 1 and 1 for CPU and SRB and 0 for the others, you definitely want to change them because, as I said, they will be changed for you soon. So do it ahead of time so you can understand the effect. Just don't do it blindly. So remember, service units could be used for accounting. So you want to check these things before you're updating Workload Manager. Are there, do you have some accounting processes downstream that are keeping track of total service units and saying this is how much service application ABC is using, and therefore this is how much we're going to charge them to run in our machines? You'll want to look at those, because if you change your CPU weighting from 10 to 1, well, now the total reported service unit is going to be 1/10 of the value. The accountant's going to go, wow, what did you do? Look at that. Everything is using 1/10 of what it used to. It's not. It's using the same amount of CPU as it used to use, but the service unit number is much smaller. Now, while you're in your policy, you're also going to want to identify any service classes with multiple periods, which is what we're going to focus mostly on today. Multi-period service classes have durations, and those durations are in weighted service units. Now, this really isn't an optional exercise unless you never plan to upgrade ZOS. If you're going to stay on pre 2.5 for the rest of your days, then in theory, you can stay where you are and that'll be just fine. But as of 2.5, assuming you do upgrade, the coefficients will quite literally disappear. The values will be fixed internally, and total service units will be equal to unweighted CPU service units. That's it. That's all. No IOC, no MSO, and no higher multiplier for CPU either. So let's take a look at unweighted service units. So a little table pasted here out of the SRM constants. If you're not familiar with these, link at the bottom there, but I can tell you, just Google IBM SRM constants and should be the first link you find. It's kind of like the LSPR. There's two really useful tables that IBM maintains, and they maintain them very well. You know, this is right up to the latest. Z15, both SRM and LSPR will be current, and you can go all the way back to the bipolar machines. Even their numbers are there if you happen to have one of those lying around. The idea being that you can say, well, what is the service unit rating for a core on this box versus that box, so I can see what that's going to look like as I change hardware. Now notice in the table snippet here, the service unit SU/sec, that's service units per second column. That's providing the service units per second rating for each processor model. These are raw CPU service units that will land in those CPU and SRB buckets. Again, if you're weighting by 10, well, then that value, that 14,000 is going to be multiplied by 10, and it's going to say 140,000 for every second. Now, just for a little bit of context, the single core full speed Z15 is rated at over 100,000 service units per second per core. You might notice here we're looking at one of these sub-capacity machines at the top here. I kind of kept this one mainly because you could see the titles, but as you scroll down, they go on and on and on. This starting at 401 up to 406. So if you compare that, these tables will give you a quick reference for just say basic CPU time comparison. The job that consumes 1 million service units today, running on that full speed Z15 that can produce 100,000 per second, that's going to take around 10 CPU seconds to run. That same job run on this smaller 401 that only produces 14,000 service units per second, that's going to take like 70 CPU seconds to complete. It's really just a comparison of the relative speed of the core. It's quite literally, in this case, pretty much clock speed. Notice also the point at the bottom here that these are accounting for the MP effect. You can see the 401 all the way down versus the 406. Now, this is the same hardware. I got 1 core versus 6 cores. They're the same physical hardware, same cores running at the same clock speed, but you have a slightly lower service unit rate as you increase the number of cores on a machine. That's the MP effect, and that is accounted for here. So let's talk about multi-period service classes. So we've been talking about individual transactions so far. That's what consumes service. Obviously, service classes themselves are really just logical constructs where our jobs and transactions run. Now, besides accounting, this is where service units become important. Again, with multi-period service classes. WLM doesn't actually manage service classes per se, quote unquote. It manages service class periods, and each period has its own goal and importance. You could make them the same if you want, but that would make a lot of sense. And every service class has periods. Many of them just have one, that's all. So for service classes with multiple periods, all but the final period will have a duration. As I said in the abstract, what's a duration? Well, duration, it's not wall clock time, and it's not even CPU time. Duration is total weighted service units. So hopefully now it's becoming a little bit more clear about why you really want to understand how these service units are calculated and how you can change them. So as we discussed so far, transactions, and I'm using the term transactions because really in a WLM context, everything, even batch jobs are called transactions. If you look at a RMF workload activity report for any service class, including batch, you'll find several fields referring to transaction counts and rates. If this were a batch service class, the number of completed transactions is the number of completed jobs. That's all it means. They just call them that. In a single period service class, a transaction will run as long as necessary under the same goal until it's complete. Straightforward. Its accumulated service units can be tracked, but they'll have no bearing on how Workload Manager treats the transactions under that workload. As I mentioned a moment ago, multi-period service classes have durations for each period, except the last one. When you get to the last one, you just run forever until you're done. If a transaction exceeds the specified duration for the service class period in which it's executing, it will automatically move to the next period. Now, typically, the next period will have a different goal. Recommended it should be a more modest goal. And that transaction will automatically be reclassified to that new goal. This is automatically, which is kind of nice. I mentioned the bottom here. This design has the effect of automating priorities based on consumption. The more you consume, assuming that you make more modest goals, lower down the chain in successive periods, the lower your priority will be if you're running longer. So the general effect here is that you're very short, low consumption, we'll call well-behaved, if you will, transactions that will generally complete in the early periods, and they will enjoy the highest priority, which you would generally want to set for, say, a first period. And then the longer running, higher consumers will begin at that same high priority, but they'll have their priority lowered automatically after they've consumed the specified amount of service and then move to the next period. Now, to achieve this, as I'm kind of alluding to here, you really want to follow this recommended approach and set less stringent goals in each successive period. You don't have to. I have seen multi-period service classes with almost the same goal from one period to the next, and that kind of defeats the purpose, because it'll exceed the duration, it'll move to the next period, but it's pretty much the same goal. It's going to run the same way, so you haven't really achieved anything by doing that, and you're increasing the number of active service class periods under management by workload manager, which is not a good idea. Now, for the final period, generally speaking, you want a low velocity or maybe even discretionary is a good idea, because just remember that final period has no duration whatsoever. So the longest running transactions that consume the most CPU are going to run in that final period after they've transitioned through the first few until they complete, and whether that's in seconds or hours. Okay, let's look at an example. So here we've got a fairly straightforward 3-period service class. Period 1's got a percentile response time goal, 90% of transactions complete within 50 milliseconds, 0.05 seconds, with an importance of 2. And the duration is set for 1,000. Remember, this is total weighted service units. So, go back to the SRM constants and take a look at your coefficients. If your coefficient today, your CPU coefficient is 10, well then I only actually need to consume 100 raw service units to get to this number. So this is where the weighting really matters. So this is total weighted service units, and total. I'm really focusing on CPU, and for the most part, that's where we should be focusing our time. But pre ZOS 2.5, it does consider all of them. It's going to add them all up. The second period, we switch to a moderate velocity of 40, reduces the importance to 3. Again, this is kind of following the general best practice of less stringent goal as you move through the periods. The duration for this period is also significantly longer at 2 million service units. It might seem like a lot, but really it's not if you think about it. And then the third period drops to discretionary. So if you've consumed 2,001,000 in total weighted service units, and your transaction is still running, you're going to now be in discretionary. The idea being, if you consume less that, you won't ever get to discretionary. You'll complete before you get there. So just for a little fun and context, let's assume, look in the right, let's assume this is running on a mid-size Z14 10-way machine, each core rated at 75,000 plus service units. This will give us some general context about how much CPU the transactions in each period can get. So I know it's afternoon for you guys, it's morning for me, but that's okay. We can do a little bit of basic math. I don't think I'll hurt myself. So one of the key exercises you really should go through when setting goals and durations or reviewing them is firstly making sure those values are reasonable on your hardware, making sure they're possible, and we'll talk about appropriate in a moment. So here we could first divide our first period duration by the service unit rating of the machine. We can see the hardware can produce 1,000 service units in around 10 milliseconds. Our goal is only 50. So that gives us a basic assurance that this machine should not have any problem providing enough horsepower to meet the goal within the chosen duration. Now, as I just kind of mentioned, we're not assessing here at this point if this goal is appropriate. We're just estimating if it's achievable on our hardware. If the service unit per second rating was significantly lower, or if the duration was significantly lower, you could get yourself in a situation where it's just not able to complete, depending on what the workload does. We'll talk a little bit more about appropriate later. You could also, for fun math, contrast the goal directly with the machine rating, which tells us, the bottom right there, if the transaction ran and consumed CPU for the full 50 milliseconds. So remember, this is not 50. We're saying it actually used 100% of the CPU for 50 milliseconds. In most jobs, response time and CPU time is not one and the same. It will have, in that case, consumed over 3,700 service units, and obviously it would have migrated to the second period by then once it passed 1,000. So what about the middle period? One of the common strategies, which is a good idea, try and size the first period to complete the bulk of very short transactions. But some transactions are not necessarily hogs, they just might have more work to do. So if you decide that more than 2 periods are appropriate, I'm personally a fan of a really good sized second period. By this, I mean, just because transactions that land here weren't lightning fast doesn't automatically assume they're CPU hogs either. You get month end, for example, you're going to use a little bit more. That doesn't mean you need to punish the workload. As long as the importance is lower than your loved ones, which we do here, the importance takes down a step from the first period, and the goal is a little bit more modest. It's reasonable to give these transactions a decent amount of time, and by time we mean CPU time, not wall clock time, to complete. So if you think about these middle ones, rather than say long running transactions, think of them as short running batch jobs. Classify them accordingly. You probably have, like, what you might call hot batch compared to, say, regular batch, and that gets a little bit of a premium. Now, also, this example of 2 million service units might seem like a huge number, but doing the basic math here, it translates to around 26 seconds of CPU time on our sample 10-way Z14. Now, for interactive transaction, that's a pretty long time, but for a batch job, which is kind of starting to look like either short batch jobs or long transactions, that's not necessarily out there. And considering that transactions do other things besides just use CPU, besides I/O, this might include transactions with even a minute or more of wall clock time. The idea with the fairly generous second period, assuming that you go for 3, which is what we have in this example, is that only the true hogs, if you will, or looping transactions that just eat CPU forever, are going to be the ones that are going to fall through to the final period, which in our case is discretionary. If they're still eating CPU after a really healthy second period, then they're now taking on the profile, the behavior of long-running batch jobs, and they should be treated as such. So when can I, and when should I, utilize multiple periods? They're not for everything. Now, I hope the KICS folks in the room, if there are any, haven't been thinking furiously about how they can apply this to their transactions, because they can't, sorry. KICS reports consumption differently to Workload Manager, so multiple periods simply aren't supported. Just doesn't work. Doesn't work for IMS either. Sorry, I didn't build it, but that's okay. Of course, you can have different response time goals for various transactions that run in a region. If necessary, you could, for example, limit consumption by classifying regions under resource groups, but that's really gets into an entirely different discussion. Maybe a whole other presentation. Okay. Multi-period service classes have been very popular with TSO for many years. and for good reason. When a TSO user is just, say, scrolling through SDSF, right there, this is not an expensive transaction. Like hitting enter or scrolling down is technically a transaction. You're going to interrupt the CPU and do your thing. That should be snappy from my perspective. You want that to run quickly. Somebody shouldn't be waiting a long time just to scroll. Whereas, say, an intensive background task that could also be run in someone's foreground TSO, that shouldn't be allowed to compete with other TSO users that are doing something as trivial as scrolling. That's why multiple periods work really well with TSO. You do the quick stuff, you get in and out. If you're still running, you start migrating down, everybody's happy. Besides TSO, if you think about it, this technique of multiple periods is almost custom made for DDF. And that's where you see it a lot. And it's, as most of you know, DDF is that workload that's often very important to the business, but also, I'll say, shall we say, very volatile in its behavior. I've heard Martin use the term feral, and now all DDF is not feral, but I can recall some 20-something years ago being woken up in the middle of the night when this stuff was brand new, and I had to go into the data center, and they said, "What is this enclave stuff that's eating our machine?" Anyway, using a basic 3-period design like we just looked at in the previous slides can work very well with DDF. The short-running, well-behaved critical transactions get in and out, and you can safely give them a high priority because you've got a short duration. Those that run a bit longer, they'll still do okay. They'll move down to that middle period and get a decent amount of service. And the hogs, which inevitably there are some that can ruin your day, will drop safely down to discretionary. And really, with this design, you can make a reasonable case to your developers. The more efficient your application, the better service it will receive. Kind of a democracy. Even some batch shops could be good candidates. At my old shop years ago, the network folks used to run thousands and thousands of jobs. They were called transmission jobs. They're submitted as batch, but they literally only ran for a second, and they consume virtually no CPU. So I don't want to treat them just like any other job. The first period might look something like a transaction second period. So using that technique, I'm able to get all of those quick jobs in and out, keeping my multi-programming level under control, and not wasting initiators on a bunch of jobs being clogged up behind longer running stuff. Okay, how are we doing for time? Let's look at some data. CPU per tran, pretty core metric. Very, very useful in many, many contexts. Now, these stats here are from the ARM-F72. Just briefly, be careful if you reference CPU per tran from other sources. Other records often only group by service class, not service class period. They might not break them up like that. So you could be seeing all transactions from all periods. And in order to check CPU consumption in this case against duration, you want to be able to separate by period, which you can do within the 72s. You want to ensure you're only counting the transactions that completed within your period. With CPU per tran, you can easily convert that to a service unit value for your specific hardware. And this chart is a 24-hour view, so it's not really surprising to see more variation at night. We could tighten that up or just ignore that. During the day, which is likely when we most care, the CPU per tran is pretty steady, in this case, right around 2 milliseconds. This is something that we can reference right out of the gate. Then response time, which is not just CPU time. Transactions do other things, but the same rules here. You want to know the response time for this period, not the average for all periods across the service class. Again, when you're only talking about a single period service class, response time for the service class for the period is one and the same. There's only one period. But with multiple periods, there you will get a different response time for each period, and they can vary widely because they have different goals, obviously, and different profiles of workloads. So here we see a fairly steady response time during the day, about 12 milliseconds. The goal for this first period is a modest 50 milliseconds. So now let's play performance analyst. I like to pretend I'm one from time to time. Both the achieved goal and the duration in this example are well within the specified range. So just because we know it's achievable, is it appropriate? Spoiler alert. Anybody that wants to guess, I'm going to briefly pause. Okay, I've paused. Moving on. Now, many of you might be familiar with this concept of overachievement. When we talk about performance indices, the basic rule is, okay, 1, I'm meeting my goal, greater than 1, I'm missing my goal, less than 1, I'm overachieving my goal. And for the most part, people just think, well, as long as I'm under 1, I'm good. I only care if I'm over 1 when I'm missing my goal, and then I need to fix that. Well, beware overachievement. So this chart shows the performance indices for all 3 periods in this service class. The red line, which is the second one down from the top, is the first period PI. And we can see it's consistently around 0.5 throughout the day. Now, PI is less than 1, or PI 5, 0.5, it's less than 1, right? So that's good. I'm meeting my goal. What's the problem? Well, for Workload Manager to help workloads that are not meeting their goals, it needs donors. And workloads that are far overachieving their goals are at risk of being selected as donors. And more specifically, WLM views performance indices lower than 0.8 as significantly overachieving, which is the case here. That means you've only asked for a certain goal and you're just doing way better than that goal. So I can steal from you and you'll still make your goal, so you won't complain. Now, you can artificially protect this by using, say, the CPU critical option, for example. But when the more you do that, the more you really interfere with the natural process of WLM doing its job with measuring workloads, meeting goals, donor, receiver. So it's usually just better to adjust the goal. As many of you know, setting WLM goals can be as much art and science, and we don't really have time in this session for a detailed discussion. But suffice to say, it's not necessarily bad to make your goals a little bit challenging, at least for your critical workloads. You do want your PIs higher than 0.8, so they're not donor candidates, but obviously you don't want them missing badly. So even PIs of, say, 1.1, 1.2 can be good. This will ensure that Workload Manager pays attention to your loved ones. Now, again, just briefly here, I'm watching the clock, not to diverge into a detailed Workload Manager discussion, but this further enforces the point about overachievement. With percentile goals specifically, Workload Manager distributes completed transactions across 14 buckets based on a percentage of the chosen response time. So there will always be 14 of them. The values will depend on what the chosen response time is for the goal. Now here we can see that over 90% of the transactions are completing in less than half the specified response time. That's this lowest orange line here that says percentage of transactions less than 50% of goal. It's actually 14 buckets, as I mentioned here. I've just kind of cut them down to see 4 of them for relevance, because the big point here is that over 90% are doing twice as good as what you asked for. That's partly why those PIs are so low. It's really, really overachieving. And there's a percentile goal where the goal is 90% under a certain period. Well, yeah, they're under it already. They're under half of it. We also saw previously first period transactions only consumed it was 150 service units, and the specified duration was 1,000 service units. So there's a reasonable opportunity here to reduce the goal, tightening up the buckets, and reducing the duration, which will restrict that first period really to a more uniform set of short running transactions only, which is really going to help workload manager manage that response time. You also want to look at ended transactions in each bucket. Now these two charts, it's the same data. They show the count of ended transactions in each of the 3 periods. Essentially, this is a distribution of where everything ended after obviously all starting out in the first period. The top chart does have all 3 periods in it, but you can really only see the first period, as the peaks of first period have 2 million transactions ending in an interval. It really dwarfs the number of transactions ending in the lower ones, which is generally what you want to see. But just to be able to see those numbers in the bottom chart, same data, and what I did was I removed the first period data. So you can actually see how many landed in second period, and we can see the second period actually still hosted a respectable 40,000 transactions in an interval. There's quite a few in there. It's just a long way from 2 million. Third period volume is literally insignificant. I think in many cases it was even single digits, which is what you would hope for, because again, using that very large second period strategy, there shouldn't be a whole lot dropping all the way down to the bottom, and unless they're real hogs. But the hypothetical question might be posed here, is one of those common design points around multi-period service classes, to get as much work as possible done in first period. Well, let's just take a look at the second period profile. The top chart on the left here is from the previous, showing me the number of ended transactions, that 40,000 peak in an interval, and also the total CPU time for all the transactions in that interval. If I divide those out, I get my CPU per tran in the right chart. Now remember, our first period CPU per tran, that was around 2 milliseconds. This second period CPU per tran is like 10 times that and then some. It's between 20 and 40 milliseconds. Very, very, very different profile here. It's not even close. So it just doesn't make sense to lengthen this first period duration, even though you might want to say, hey, this 40,000 is a lot. Can I get more than the first period? No. And really, in fact, given what we previously looked at a first period distribution, that first period duration would probably be reduced. And also consider second period has a velocity goal. It's not subject to that distribution, those 14 buckets. That strictly refers to percentile. For average response or for velocity, it's really just an average of everything together. And just another perspective to, another way to look at things, plotting total CPU for each period. We can see what kind of stands out with us here is the blue is second period. That's where most of the CPU is. This is independent of transactions. But if you contrast that, you can put them in the same chart if you want for interest. But what we saw earlier, we already know that from a transaction volume perspective, first period was completing at peak 2 million transactions in an interval versus second period completing 40,000. So really just the overall efficiency from this particular perspective is very, very clear. You're doing 2 million transactions in first period, but they're relatively cheap. So as the note here, it's entirely appropriate that the less efficient workloads, second, third period, will run at what I would call a less threatening priority. One of the points I always like to make in mainframes in general is that a mainframe is a large shared ecosystem. And the key word I like to emphasize is shared. In the distributed world, if you only have a single application on a server, you can give that application the world and give it everything it wants. Sometimes we get into maybe theoretical disagreements with some of the folks in the non-mainframe world, where if you ask an application person, is your application important? What priority should it be? Well, what are they going to tell you? tell you, of course it's important. It should be top priority. Everybody should be top priority. If you've been to any of my sessions before, you've heard kind of my perspective on that. You can't give everybody top priority, and it's just not efficient to do that. But the ZED infrastructure is really incredible at managing lots and lots of work, as long as you prioritize things accordingly, and not try to put everything at the top of the food chain, because that just won't work so well. Just one last chart here, expanding by LPAR. We've been looking at total transaction rates, CPU time, response time across the Sysplex. As most of you probably know, WLM scope is by Sysplex. Obviously, there can be multiple LPARs in a Sysplex, and those LPARs can be on different capacity machines. We can see from this breakdown that there are 3 LPARs hosting these particular transactions, which may very well be on different machines. You can see each of the 3 periods for each of the 3 systems, that there is some work running on all 3 LPARs and running in all 3 periods, but the distribution is certainly not even. We can see the vast majority of first period transactions are running on 2 of the 3 LPARs. And the hardware could be very different. The configuration of the LPARs could be very different. So you just want to bear this in mind as well. WLM is going to first try to achieve the Sysplex goal for the workload, and then he's going to follow by trying to achieve that goal on each LPAR. And the relative difficulty of achieving that goal in each LPAR may vary based on the amount of work going there and based on the capacity of that environment. So when you're looking at all these metrics we've discussed, CPU, response time, et cetera, it's really a good idea to also contrast these across all of the LPARs in the same Sysplex. And I see I am getting close to the top of the hour, and I want to have a little time left. So just a few of my own personal recommendations. Even though we've been talking about a lot of detail, you really want to avoid too much micromanagement. Too many active service class periods can be unhealthy. Most of us know this. So if you take 5 of your existing single period service classes and say, hey, Baker says this is a good idea, I'm going to make all 5 of these 3 periods each. Well, okay, except now instead of 5 service class periods, you have 15. And there's a general rule of thumb out there, but you don't really want to exceed, say, 30 active service class periods, because WLM has to manage them all, and he's really only going to help one at a time. So don't go crazy. Number of periods. Historically, I've seen some TSO setups with 4, 5, 6 periods. You really shouldn't need that level of granularity. Generally speaking, I'm not saying there couldn't be exceptions, but I think 3 is plenty. In some cases, even 2 is enough. You got the fast running stuff, the slow running stuff. It'll obviously depend on what kind of distribution you have. And that's where you want to look at the workloads and say, how much CPU does this workload use? If they're dramatically different, you might even consider, well, maybe they shouldn't even be in the same service class grouping at all. But in many cases, if you've got a fairly uniform distribution, as we saw the example here, where 2 million of them all fall into that short period, well, that's great. And then I got some middle ground, and then a handful of bottom feeders. That should be just fine. You want to start by correlating your actual response goals with the transaction distributions, durations from your SRM constants, and then tighten them up, as we talked about. Remember, first period, that's for your critical. Short running transactions, keep it tight. Percentile response time works well. I think you'll find that's the general recommendation. People prefer that over averages. Again, my opinion, be generous with that middle period, provided it does not also use percentile response time goals. That would be an exception to that. You don't want to start mixing percentile with long durations, or you might be asking for trouble. This only allows those true hogs to drop down to the bottom. Remember that Sysplex scope we talked about, bear in mind varying capacity. And finally, independent of the ZOS 2.5 change. We know this is coming and it's going to happen to you, whether you plan for it and do it yourself or not. But even if you're not immediately moving, even if 2.5 is a couple of years out for you, when's the last time you reviewed your existing multi-period service classes? How often have you changed hardware or configurations during that time? Has the application profile changed? There's a really good reason to review these things, because WLM is just going to do what you tell it to do. It's entirely possible you might have really inappropriate durations. And so kind of mentioned the abstract. It's a really powerful thing, can really protect the important work, and it can really cause havoc if not managed properly. Okay, I think I'm pretty close to the time. Piara said, please submit your feedback. I believe the QR code here even works. I tried to copy that. So if you're pointing at it with your camera, that should work. Or you can go to the link there. This is session 6AV. I do see, oh, okay, Piara is letting me know on the timing. Thank you. If there aren't any questions, feel free to post them in the chat box or.
Yeah, thanks very much, John. If anyone does have any questions, as John said, just please feel free to put it in the chat box. Or alternatively, can they get in touch directly with you, John, if you've got an email?
Yeah, why didn't I do that, Piara? I'm not, it's not very bright of me. john.baker@intellimagic.com. Yeah, should have posted that in here.
All right, so if anyone does want to get in touch with John directly, then yeah, please feel free. Otherwise, if you've got any questions for John now, then you can type away in the chat box, or I can bring you up on stage if you prefer to ask in person. So yeah, I'll just give it a few minutes for people to ask anything they want.
Get on stage. How cool is that? Hopefully someday soon we'll be getting back on stage.
Yeah, comment from Patrick. Great presentation. Yeah. Time to review those 10-year-old durations.
Yeah, isn't that the truth? Yeah, thanks, Patrick, for that comment. Yeah, very common.
Okay, yeah, well, if there's nothing else coming in, then I think we can leave it there. Thank you so much, John, for the presentation. It was really informative. Yeah, like I said, if anyone's got any questions for John, please feel free to get in touch with him directly. We would appreciate the session feedback, and I've left links for that in the chat box. And also we'd appreciate if you could donate to our nominated charities as well. It'll give you a chance to take part in the special prize raffle. But for now, thanks everyone for joining. We'll be back in here at 2:30 GMT. So yeah, just in about half an hour. Where we'll be hearing from Frank Kine from Watson and Walker.
Oh yes, don't miss Frank.
Yep.
Love Frank.
Awesome. Thanks everyone for joining, and take care.
Thank you.
Thank you. Bye-bye.
Bye now.